Okay, so good evening, everyone. So here are we today after the INICET exam for the recall session of ophthalmology. Now, as per the exam pattern, the ophthalmology questions, they were, kind of on the tougher side of the spectrum. There were some, not that easy questions were asked from the ophthalmology side. I could recollect only 5 questions from the ophthalmology, and they were somewhat tough, okay, not so easy. So we'll take a quick revision or the quick recall of the options and the correct answers, so you can get an insight about the answers and you can get to know whether how you have attempted the question. But just going starting before the recall session, I just want to say that you have done your best, you have given your exam. Even if you could not perform well, do not lose hope. Okay, do not get disappointed by the recall session if you get your questions wrong. So because at the end it is just an exam. Okay, the summary is that at the end it is just an exam. So if not this time, the next time, okay, NEET, next year NEET or the next INI, okay, this exams they will come again, okay. So you don't have to lose hope. You have done your best. Even if you could not give your best, you have, and if you do not get good results, give your best the next time, okay. The only thing you have in your hands is to give your best. Keep working hard, keep working smart and hard, and do your best, okay. And the results will be fine. The results will be good if you give your best. So let us start with the ophthalmology session. The first question is true about glaucoma. So the true statement about the glaucoma. Last time we did the recall session, the questions about the glaucoma they were asked. Every time in INI, one question from the glaucoma, as it is a rule. It has become a rule. They always ask one question, and this time they have asked 2 questions about the glaucoma. So glaucoma is asked in NEET-PG also, but in NEET-PG we have more number of questions. In INI, always glaucoma question is always asked, and this time 2 questions have been asked. So glaucoma is very important per se from the INI point of view. So this time they have asked about a diagnostic condition of the glaucoma. So the first option is isopter contraction with bearing of blind spot is the earliest and the specific feature. If we go by this statement, isopter contraction with bearing of the blind spot is the earliest and specific. This statement is half correct and half wrong. Yes, because it is the earliest feature, but it is not the specific feature. It is the earliest, but not the specific feature because it is seen in other conditions also. If we talk about the specific feature, paracentral scotoma or the germ scotoma, they are the specific features in the perimetry when we talk about glaucoma. But isopter contraction is the earliest and the specific and the non-specific feature. This is the first line we always teach whenever we talk about the visual fields. This is a very taught statement, and this is an easy to track. Next statement is in static perimetry, intensity of stimulus is kept constant while it is moving. Now, if we go by only the literal meaning of the term static, static means it is stationary, it is not moving. So it means in static perimetry, the stimulus, it is not moving. Okay, it is not moving, it is constant. What is changing is the intensity of the stimulus. So this statement is the direct opposite of the actual true statement. Here, the intensity is changing, but the stimulus is static. The stimulus is stationary while the intensity is being changed. So in static perimetry, intensity is changing, but the stimulus is stationary. So this statement is a wrong statement. Kinetic perimetry is best for monitoring visual field changes in a patient with glaucoma. We know that there are 2 types of perimetries, kinetic and stationary, and as their literal meaning suggests, in static the stimulus is stationary, in kinetic the stimulus is moving from periphery towards the center, and the area where the patient responds to the the stimulus, we assume or we can find out the visual field of the patient. Okay, so in kinetic, the stimulus is moving from the periphery towards the center. But when we talk about the perimetry, kinetic perimetry and static perimetry, the static perimetry is a better test. It is a better test for monitoring the visual field changes in a glaucoma patient. The example of static perimetry is the Humphrey. It is the Humphrey perimetry, which is a better diagnostic tool than the kinetic perimetry, which was used in the earlier time. And kinetic perimetry is more commonly used in neurophthalmic conditions, while the Humphrey, that is an example of static perimetry, is used in the glaucoma diagnosis. So this statement also is a wrong statement. So the last option is obviously the correct, but let us study it. Visual fields defects are classified as glaucomatous only if they are associated with the relevant optic nerve head changes. Okay, we know that what is happening in glaucoma is a death. Which simply, what is glaucoma? It is a death of the ganglionic cells. So whenever there is ganglionic cells and subsequently the loss of the nerve fibers, there will be defects in the retina due to the loss of the nerve fibers, and these retinal changes, they are shown on the visual fields. They are shown on the visual fields. Okay, so whenever there are optic nerve head changes because of the loss of the nerve fiber layer, they are these are the changes which get reflected on the perimetry. So the visual field defects, they are associated with the relevant. If the optic nerve head changes are not there, how can visual field defect can detect any damage? Okay, so this statement is a correct statement, which states that the visual fields defects, they are classified as glaucomatous only if associated with the relevant optic nerve head changes. So this is the true statement about the glaucoma. And this is the, we always study about the visual field changes in the glaucoma. We know that the first is the isopter contraction. First is the isopter contraction with the bearing of the blind spot, but the specific is the paracentral scotoma. So the answer to this question becomes 4. So let us now move to the next question. In this question, you were asked about the identification of the marked structure, and this area was being marked. This area was being marked. Whether it was the actual image, it is not known. So this image or this area was being marked and asked about the identification. Okay. Now this was, kind of a difficult question among all the questions in the ophthalmology. This could be regarded as the toughest question. So this was just an anatomy question in which you were asked to identify the structures. Now let us learn about the structures one by one. So we know that the lens is attached to the highlight. What is highlight? Highlight is basically what the lens is attached to the highlight with the name of a ligament that is known by the name of Weger's ligament. Weger's ligament, which then continues in the form of a canal, that is the Flockett's canal. And the space between the lens and the highlight is the Berger space. It is the Berger space, and this is the Flockett's canal. This is the Flockett's canal, in which the primary vitreous is present. Okay. Now, when we talk about these canals, given in the options, one is the canal of Pettit, canal of Honaver, lens capsule, and Egger's line. We can easily rule out one option, that is the lens capsule, which is not, because the lens capsule is this area. Okay. Now we talk about the canal of Pettit and canal of Honaver. These are the zonules. These are the zonules, which are present. These are the zonules. These are the zonules, we know that, which originate from the ciliary body and get attached to the lens capsule. Okay. So the space between, we know this is the equator of the lens. This is the equator of the lens. And according to the location where these zonules are present, they have been given their name. For example, the zonules which are attached before the equator, they are known as pre-equatorial. Behind the equator are post-equatorial. And the space between the pre-equatorial and the post-equatorial zonules is known by the name of canal of Hanover. And similarly, the space between the post-equatorial zonules and the anterior highlight is the canal of Petit. Okay, this is the lens capsule. If this is my lens, these are the zonules attached. This is the equator of the lens. Pre-equatorial, that is anteriorly attached, and the post-equatorial. The space between them is the canal of Hanover. Okay, Hanover. Okay, and the space between the zonules, post equatorial and anterior highlight. What is anterior highlight? Anterior surface of the vitreous is the canal of Petit. Okay, and next option is lens capsule. We know that what is lens capsule. The fourth option is the Egger's line. What is this Egger's line? Is basically the Wiegert's ligament. We know that what is Wiegert's ligament? Posterior part of the lens capsule where it is attached to the vitreous is with the help of Wiegert's ligament. This Wiegert's ligament basically Egger's line, Wiegert's ligament continues as Egger line. Egger line is nothing but just the communication of the posterior lens capsule with the anterior highlight, which then continues as Wiegert's ligament and finally into the Cloppich's canal. So Egger's line is the communication or the attachment of the posterior lens capsule with the anterior highlight or the anterior vitreous. Okay, which then continues as Wiegert's ligament. While the canals of Hanover and canals of Petit, they are the spaces between the zonules, between the ciliary zonules. Okay, so in this, the option which was asked was the canal of Petit. The option asked was the canal of Petit. Okay. The next question is sequence of staining in dry eyes. So the fourth option, I don't know if there was any fourth option because we use mainly three stains, not even three. We use only mainly one stain while we talk about the dry eyes, but three stains they have been studied for the diagnosis of the dry eye. First is the fluorescent stain, Lissamine green, and rose bengal. Okay, we always discuss about the fluorescent stain. Its various uses not only in the dry eyes but in ophthalmology. There are many uses of the fluorescent stain. Lissamine green and rose bengal stain. They mainly Lissamine and rose bengal stains mainly the dead cells, mainly the dead and devitalized cells. They stain the devitalized cells, while the fluorescein stains the live cells. It stains the live cells. One basic difference between these three. The next main difference is fluorescein stains cornea better than conjunctiva. It stains cornea readily than conjunctiva, while Lissamine green and rose bengal, they preferably or better stain the conjunctiva. They better stain the conjunctiva than the cornea. Okay, two main differences between them. Fluorescein stain, we know that if you can be asked is, it is, something yellowish orange looking type of the stains. Okay, we see it under the cobalt blue filter and it appears green. At the end, it appears green because it emanates the green color. It absorbs the blue filter and emanates the green color, which is the final reading which get in the form of a green color stain. Lissamine green, as the name suggests, it is a green color stain. Rose bengal stain is a pinkish color, reddish color stain. Okay. So this is the third difference between them. The fourth difference is fluorescein is a very well tolerated stain. Lissamine is also a well tolerated stain, while the rose bengal it stings. Rose bengal is an irritating stain. It is an irritating stain. That is why it is not used in the clinical or the practical purposes. While Lissamine is also very less commonly used, and rose bengal is not used in the practical purposes. Fluorescein stain is the most common stain used. It is the most common stain used. So if we are asked about the sequence of staining in the dry eyes, we have to use fluorescein most commonly used, Lissamine and rose bengal. So the answer to this question will become 1, 2, 3. Fluorescein, Lissamine and rose bengal. Rose bengal, it is a very irritating stain, not used. Lissamine and rose bengal, again They are not preferably used because they mainly stain the conjunctiva, while fluorescein, it mainly stains the cornea, which we want to study whenever we are discussing about the dry eyes. So this is the diagram. This is the fluorescein stain. This is the fluorescein stain, in which the stain will appear as green because of the the light rays it is emanating. This is the lysamine green stain, and this is the rose bengal, which stain the dead and devitalized cells, and the fluorescein mainly stains the spot. So the answer to this question will become fluorescein, lysamine, and rose bengal at the last, because it is the most irritant stain. Next is, which of the following is the direct gonioscopy? Again, question which was on the tougher side. So, firstly, let us quickly revise about gonioscopy. It is a technique to examine the structures in the angle, and thus, because it is examining the angle, it is differentiating between open and closed angle glaucoma. And what principal gonioscopy is based on? Because we know in normally slit lamp examination, the angle is not visible. And why it is not visible? Because of the TIR. What is this TIR? Is total internal reflection. Total internal reflection. And what does this total internal reflection mean? Whenever light passes from a denser medium to a rarer medium, from a medium which has a high refractive index to a medium which has a low refractive index, the rays, they bend away from the normal. Okay, they bend away from the normal when the light passes from a medium which has a high refractive index to a medium which has a low refractive index. So if we increase this angle will increase. So at one point of the time, the refractive, this way, it becomes parallel to the surface, or the angle becomes 90 degrees. This angle becomes 90 degrees, and this is known as the critical angle. This is known as the critical angle when the angle of the refracted light ray, when the angle of the refracted light ray becomes parallel to the interface, or becomes 90 degrees to the normal. And if we further increase this angle, this light ray will not refract further. It will reflect. It will not refract, but it will reflect back. It will reflect back. And this is known by the phenomenon of total internal reflection. And because of this, total internal reflection happens in the cornea. The light rays goes back again into the anterior chamber. We are not able to see the angle or the structures of the angle whenever we see on the slit lamp examination. To solve this, we use some lenses. There are two type of lenses, mainly direct and indirect. In direct lens, there is just a lens. Okay, you just have to remember, in direct lens there is one lens. Okay, gonio lens. What is happening in indirect? In addition to lens, there is also mirror. Okay, this is indirect, so it has to have a mirror. It has to have an extra thing. This is indirect, and if there is only we are putting a lens and we are seeing the structures, this is direct. When we are putting a lens, we are still not seeing the structures. We need a mirror. This is known as by the name of indirect gonioscopy. Simple. But what is happening in actually direct is the curve of the gonio lens is such that the critical angle is not reached and the light gets reflected. While in indirect, the light rays are reflected by a mirror in the lens, and then it leaves the lens nearly at right angle to the lens air interface. What this lens here we mean is the gonio lens, which we are putting before the exam. Okay, so there are two types of the gonio lenses. Direct, we only need the lens. Indirect, apart from the lens, we need another thing, that is the mirror. So this is indirect gonio. Okay, so the examples are Poppies, Richardson, and Swan Jacobs. They are the examples of direct gonioscope, or the gonio lens, sorry, and indirect Goldman, Allenthorpe, and Zeiss. They are the indirect gonio lenses. Indirect, they are more commonly used in the clinical practice. It is most commonly used are the indirect gonio. Okay, so in the options, we were asked about the direct. So the direct, they are the Poppies and the Richardson. So the answer becomes Okay. So the next and the last question is, this is the clinical picture of a patient before and after the use of phenylephrine eye drops. So what is the diagnosis? Okay. So the options are episcleritis, scleritis, and phlex. Uh, we know that we always learn about this thing is the use of phenylephrine, because phenylephrine is a vasoconstrictor. It will blanch the vessels, it will blanch the superficial vessels, and thus it will relieve the symptoms or relieve the the congestion of the episcleritis. Now, if we go about the question, if we assume we do not know the answer, firstly, let us learn about phenylephrine. It is a vasoconstrictor, so it will blanch the superficial vessels. If we go by the name episcleritis and scleritis, we know that episclera, it is a superficial layer before the sclera. It is a superficial layer of the sclera. So, phenylephrine is going to blanch the superficial vessels, that is in the episcleritis or the episcleral vessels, but it will not be able to blanch the deeper vessels which are involved in the scleritis. Okay. But what if we talk about the flectin? We know that what is flectin? Flectin is seen in the flectanular conjunctivitis. What is it? It is a hypersensitivity reaction. It is a hypersensitivity reaction to a foreign antigen. In India, most commonly to the tubercular antigen, or in the Western world, we say due to Staph aureus. So it is a hypersensitivity reaction. It can involve both cornea and conjunctiva, but mainly seen in the limbal region. Mainly seen in the limbal region, where we see a nodular lesion on the limbal, most commonly around the limbal area. Okay, and this flectin, this is known by the name of flectin. It is mostly fluorescein positive. It stains with fluorescein. It is a fluorescein positive nodule, and it can lead to dry eyes. It can lead to the loss of the epithelial or some of the Bowman's layer of the cornea. So this is known by the name of flectin. If flectin was the answer, you would have given a nodular-like inflammation around the limbus. Next, the two options, we know that episcleritis, because it is a superficial layer, the vessels will be blanched by the phenylephrine. Now, episcleritis is both diffuse and nodular. Even in the question, we do not know whether this redness or the congestion was diffuse or it was a nodular. Even because in this image, I have taken the image of a diffuse episcleritis, but even if it was a nodular episcleritis, there is nothing to get confused about, because episcleritis is of the two types. It can be diffuse, it can be nodular. Even if there was a nodule in the picture, you should not get confused between flectin, because flectin is most commonly present around the limb, most commonly present around the limbus. Okay. And while in scleritis, the main history, the main hint given in the question was blanching. This is the clinical picture. It means this redness, it has gone. It has gone with the help of use of phenylephrine drops. It means the vessels have blanched. The vessels have blanched. Scleritis, in scleritis, deep vessels are involved, which will not get blanched by the use of phenylephrine. So the answer here will become episcleritis. The answer will be the superficial vessels which are involved, and it will be episcleritis. The fourth option is not a known option. We do not know the option, but even if it is not there, episcleritis is a very direct answer to this question. So I think this episcleritis question and the glaucoma questions, they were easier ones. This the identification question, it was a tough question. It is usually not expected at this point of time at the UG level to know this question. And while this question sequence, we always learn about the fluorescein stain only. So even if we go by this rule only, we can rule out 1 and 4 option. If these were the only options, then 2B and C could be easily ruled out, because we always study about the fluorescent stain most commonly used. It you can be getting confused between A and D, but if you know that rose bengal is an irritating stain, you could have easily answered it. Otherwise, it was a somewhat tricky question to answer. And yes, direct gonioscopy, again, it was on the tougher side of the spectrum. we usually we do not usually teach about all of the examples of the gonioscopy. We just learn about the main principle, but this was one step further to the teaching which is commonly done. And this the fifth question, that is the phenylephrine episcleritis question. It was an easier question to attempt. So in overall, in toto, ophthalmology was a little bit tough. But if you have attempted out of 5, if you got 3, it will be a very good score out of 5. But if you have marked 4 or 5 out of all the questions, then it is an excellent score. But 3 is, it will be a good score in overall if you have marked 3 of them to be right. So this was about the quick recall of the INI ophthalmology session. So I hope you people have marked the correct options. Even if not, there is nothing to worry about. You can just take them as a, add them in your notes. You can take a look at these. We'll further discuss these questions again also, and we'll, discuss other topics related to these questions also. So there is nothing to worry about. And now the exams are over. You can take a small break and then study further. Okay, so all of the best for all of you, and I hope all of you have marked the right option. Okay, good night. Thank you.